Welcome to LabMinutes.com. In this video, we will look at how to configure Cisco Tunneling Control Protocol, or cTCP, also known as IPSec over TCP, with EZVPN. So when do you use cTCP? Okay, so for example, if you have a router or your client router sitting behind a port address translation or PAT device, as you might know, the IPSec protocol is not very NAT or PAT friendly since it doesn't really have a port, a TCP port or UDP port to be translated. So the way to get around that is to encapsulate it inside a TCP headers. So when you pass through a PAT device, the packet will be basically PAT friendly or PAT compatible. Okay, another scenario that you might find cTCP useful is when you have your transit network where the IPSec packet needs to pass through. It just happened that that network does not allow ESP type of traffic to pass through. So by again encapsulating that in a TCP header, you might be able to get around that issue. So here in this lab, we already have a fully functional EZVPN setup that we took from another one of our previous video, which is the SEC0021 with the EZVPN and the pre-shared key and XAuth with the router headend. If you guys are interested or have not had a chance to check that out, you can do so because it's where we took the configuration from. So here, the router R2 acting as EZVPN client running on the client mode is currently connected to the headend R1, and we have a connectivity between the two VLAN, VLAN 32 and VLAN 128, as you can see on our ping reply that we're getting here on our test ping. Okay, so what we're going to do, just to show you the capability of cTCP, at the middle on the internet switch, we're going to create an access list that will block ESP protocol, and we'll try to use cTCP to get around that problem. Okay, so first on the switch, clear your screen, go IP access list, you can say block ESP with the access list being extended, and just go ahead and go deny ESP any, and then make sure we permit anything else. Okay, just to see if we can capture the packet that's hitting R1. Let's see if we can come up with an access list. Call from outside, permit TCP any, and let's lock it, and then permit IP any. Okay, interface fast01, which is the outside interface of R1. Go IP access group from outside in. I don't think we apply the switch access list to the interface, and that's going to be interface coming from the client router R2 on fast012. So fast012 IP access group block ESP in. Okay, so you can see as soon as you do that, the ping stops to work. Okay, so right now any data traffic that's coming from R2 going towards R1 is being dropped by the switch. Okay, so now we're going to go ahead and enable cTCP, and on the headend side, it's a global command with the crypto cTCP. If I spell crypto correctly. And here you can specify the keep alive interval or ports. So by default, the TCP port, the cTCP uses 10,000. So you can tell that, because if you do port 10,000 and look at the config, okay, although it seems to show up on the headend side, but if you go ahead and do the client side, which is going to be under the crypto IPSec client EZVPN, which is our name, and then you do cTCP port 10,000, You can see the tunnel went down and came up, and in the background here we start getting our ping back. And if you look at you can see right here where your port number doesn't really show up. Okay, so it tells you that 10,000 is the default port. Okay, and if you look, show crypto IPSec client EZVPN, and it says right here the connection is cTCP encapsulated. Okay, and it looks like we got a permitted log messages from the access list that we installed, but it doesn't seem to show you what port that was being permitted. Let's see if we can run debug IP packet real quick. Hopefully there's not too much traffic. Okay, let's stop right there. And it seems like we can only see the decrypted traffic between our client, which is 100.35 and 32.1. Okay, so you can also try to change the port that's to something else that's non-default. So if you do crypto cTCP port, let's say 2000 or 20,000 rather. Looks like it doesn't like you to change that when there's a connection up and running. So let's change on the client side first. Okay, we can also clear crypto. Looks like it went down already. And as soon as there's no active connection, it lets you change the port. And when the port on both sides match, the connection restore. Okay, again with the cTCP encapsulated. Just want to see if there's a way to, or if it's actually telling you what TCP port is being used. It looks like it doesn't really show that on the show crypto IPSec SA. Okay, so here you have it, a nifty little trick to get around some of the issue, whether it's a pad issue or network blocking ESP issue that you might run into, but just to keep in mind that once you implement these features, you just incur the added 20 byte TCP header into your packet. Okay, so it's a trade-off as far as getting things to work and the additional header. Okay, so that wraps up our VPO on EZVPN using a Cisco Tunneling Control Protocol. Thank you for watching LabMinutes.com. I'll see you guys in the next video.